Hello, I'm Sean Civic, Technical Marketing Engineer with Cisco. This video will show you how to set up and configure disaster recovery for DNA Center, which is now called Cisco Catalyst Center. So from here on out, I'll be calling it Catalyst Center. Sometimes there's some confusion between high availability and disaster recovery, so I just want to take a moment to clarify the differences between them. High availability is where you take 3 physical servers and cluster them together to act as one server. This provides redundancy and minimizes downtime in the event of a hardware or software failure. High availability requires all 3 servers to be in the same physical location. While high availability provides redundancy, it still represents a single point of failure if the entire data center goes down. Disaster recovery provides resiliency by allowing you to manually or automatically fail over to a secondary location if the primary location fails or your high availability cluster becomes unavailable. Disaster recovery works with or without high availability. For instance, if you had a single server in the primary location, you would use a single server in the secondary location. However, if you were running a 3-node high availability cluster in the primary location, you would also need a 3-node high availability cluster in the secondary location. The server sizes also have to match in terms of CPU and memory. So if you had a 44-core appliance in the primary location, you'd also need a 44-core appliance in the secondary location. If you had a 112-core appliance in the primary location, you'd need a 112-core appliance in the secondary location. They just have to be the same at both sites. In addition to the primary and secondary locations, you'll also need a 3rd location to run the witness node. The witness node is a small VM that helps determine which location is the active site. If the witness node can see the recovery site, but not the active site, it sends a signal to the recovery site to become active. Now, if the active site can't see the witness node, but it can see the recovery site, it will remain active. The active site needs to communicate with at least one, the witness node or the recovery site, to remain active. If there is a failover, there is no automatic failback scenario. Even if the original site came back up, it can only fail over once. Then you would need to manually re-register disaster recovery to fail over again. Cisco Catalyst Center is able to fail over from the primary site to a secondary site by replicating automation data. Assurance data is not replicated. Cisco Catalyst Center will start collecting new assurance data after a failover, but the assurance data before the failover is not going to be there because it wasn't replicated. Most assurance data is kept for 30 days, so if you wanted the 30 days before the failover, you could restore it from backup if needed. Now, the replication between the active and standby sites is done over secure tunnels. There are also tunnels between both sites and the witness node. These secure tunnels are authenticated via certificates, so we'll also need to install a third-party certificate. And we'll show you how to generate a certificate signing request, submit it to a CA, and install that certificate on Cisco Catalyst Center in this video. In the unfortunate event of a failover, how would the network devices find Cisco Catalyst Center if it was in a different location, on a different server or cluster of servers on a different network? It does this by using a disaster recovery virtual IP address that can move between both locations. Automatic route advertisement of that DRVIP is also supported. With route advertisement, each site can form a BGP neighbor relationship with its upstream router. The active site will then advertise the DRVIP as a /32 address to BGP, with the next hop being its enterprise virtual IP address. There's no need to set up an additional subnet just for the DRVIP. When all of your network devices are configured to talk to the DRVIP, they'll just get routed to whichever site is advertising that address. As a quick rundown of the requirements, we'll need the same number and size of servers in both the primary and secondary locations. Latency needs to be under 350 milliseconds and bandwidth needs to be 1 gigabit or higher. A 3rd location to run a small VM acting as a witness node is also needed, as well as third-party certificates. We'll also need a DRVIP as well as BGP configurations for automatic route advertisement. Okay, so let's get started setting up disaster recovery. The first thing that we're going to do is install a third-party certificate, which will be used to authenticate the tunnels between the primary, secondary, and witness node locations. The certificates received need to be signed by a trusted certificate authority. And since I'll be using my own internal CA, I'll add that CA's root certificate to Cisco Catalyst Center's trust pool. I'll do this by going to System, Settings, Trust Pool, and then clicking Import. I can download the certificate from my certificate authority by selecting Base 64 and download the CA certificate. I'll then import it into Catalyst Center. I'll then repeat the process on the other server, also by going to System, Settings, Trust Pool, and I'll import that same certificate. Next, we'll install the third-party certificate. I'll navigate to System, Settings, System Certificates, and I'm going to follow the detailed instructions in the Cisco DNA Center Security Best Practices Guide. I'll scroll down to the Manage Certificates sections and follow the steps to generate a certificate signing request using OpenSSL. The first step is to ensure that Cisco Catalyst Center hostname is set. We can verify if the hostname is set from the Cisco Catalyst Center CLI. The username is maglev, and remember to use port 2222 instead of port 22 for SSH. Run the maglev cluster network display command. As you can see, my hostname is set. Now I'll check the other server by running the same command. Here it is not set on this server. We can set the hostname by updating the maglev config by running sudo maglev-config update. I'll click next to all the interface configs and click proceed. At the maglev cluster details page, I'll enter the hostname. I'll use the same hostname on this server as the other server. Using the same hostname makes the certificate slightly easier to implement because the certificate common name would work for both. But you could also add it as a subject alternative name if you wanted them to be different. Then click Next to re-add the Linux password, which is the maglev password for logging into the CLI. Click Next and click Next again to use the same NTP server. Now that the hostname is set on both servers or clusters if using high availability, we'll create our certificate signing request. I'll create one certificate signing request and one private key using OpenSSL and use it to generate one certificate that will be used at both locations. First, we'll create a config file. I'll simply copy the sample config file in the guide and then paste it into a new file, and then I'll edit it to meet my needs. I'll enter my country code, state, city, company name, and OU. The CN or common name will be the host name or IP address of my server, and then I'll add in an email address. Under the alt name sections for DNS.1, I'm going to enter pnpserver.mydomain which is civic.local, but you would use your domain name here. If my servers had different host names, I could add another host name to DNS.2. Then, for the IP section, I'm going to enter in all the IP addresses for both locations. All IP addresses include the physical and virtual IP addresses, cluster IP and cluster virtual IP addresses, enterprise IPs, enterprise VIPs, management IPs, and management VIPs if you have configured a separate management interface, and the DR VIP or DR VIP. I'm not using a separate management interface, so I'm just going to add the cluster and enterprise IPs, cluster and enterprise VIPs of both servers, and the DR VIP. Basically, enter every IP address for every server into this configuration file and save it as openssl.cnf. The next step is to create a private key by running this OpenSSL command. Then, I'll use the config file created earlier and the private key to create this certificate signing request by running the following command. Then I'll copy the contents of the CSR, or I might send it to my CA administrator to request the certificate. Now I'm using a Windows server as my CA, so I'll navigate to 10.0.0.8, which is the IP address of my server, /certserv. I'll click on Request a Certificate and then Submit an Advanced Certificate Request and then paste in the contents of the CSR. I'll then select Web Server from the certificate template and click Submit. Then I'll download the certificate chain in a DER encoded format. I'll then convert the P7B file into a PEM format by running this command. Now, if your CA administrator gives you individual PEM files for the cert chain, you'll need to concatenate them into one file. Start with the certificate, add any subordinate CAs, followed by the root CA. Now that you have the certificate, you'll navigate back to System, Settings, System Certificate, and import the certificate, private key, and be sure to to check the Use System Certificate for Disaster Recovery box as well. And it is a good idea to encrypt it, so set a password and click Save. We'll use that same certificate on the other server by navigating to System Settings, System Certificate, and importing the certificate and private key. And remember to use the same certificate for disaster recovery. The witness node will copy the certificate from the primary and secondary locations, so there's no need to import the certificate into the witness node. Now that the certificates are installed, we can begin configuring DR. You click on the hamburger menu, System, Disaster Recovery. From here, we can see the main site, recovery site, and the witness node are all unregistered. The status box tells us to register them in the order of main site first, then recovery, followed by the witness node. Now we already have both appliances up and running, so let's download and install the witness node. I'll download the Witness OVA from software.cisco.com. I'll search for DNA Center and select the version that is currently installed. It is important that the OVA version matches the Catalyst Center version installed. Then I'll download the Cisco DNA Center Disaster Recovery Witness OVA file. Once it is downloaded, I'll deploy the OVA to my ESXi server directly, or I could also use vCenter as well. Once it's deployed, I'll go ahead and configure it by entering the password. Then I'll enter the host name, IP address, network mask, gateway, and DNS. And now that both appliances and the witness node are up and running, we can begin the registration process. We'll click the Configure tab and configure the main site first. It asks if we want to promote the existing enterprise VIP to the DR VIP. Now I prefer to create a new DR VIP instead of promoting the existing enterprise VIP. Upon activating DR, Catalyst Center will execute an automatic workflow to update the existing devices to point to this new DR VIP instead of the enterprise VIP. So I'll click No to promote the enterprise VIPs to the disaster recovery VIP. The main site's VIP is automatically populated with my enterprise VIP address of 172.21.21.10. I'll then enter the recovery site's enterprise VIP, which is 172.27.27.10, and the witness site IP address, which in my scenario was 10.36.36.36. Now, because my main site and recovery site are on different layer 3 networks, I'm going to choose route advertisement with BGP. If I had an L2 network stretch between data centers, I could choose disaster recovery VIPs without route advertisement. But in this case, I do want the route advertisement, so I'll choose the BGP route advertisement option. I'll then enter the enterprise VIP for disaster recovery of 10.10.10.10, which will now be known as the DR VIP. I'm not using a separate management interface, so I'll leave the management VIP for disaster recovery blank. And then I'll configure BGP. We do support iBGP or eBGP, and I prefer to use eBGP, so I'll just enter in a different local AS number when configuring BGP on this Catalyst Center. I'll enter the upstream router's IP address and remote AS number. And since I prefer to use eBGP, so like I said, I'll use a different local AS number. In this case, it'll be 65,001. You can enter up to 2 routers per site by clicking the plus sign. However, I only have one in my lab, so I'll just move on and enter the remote router's IP address for the recovery site, followed by the remote AS, and again, a different AS number, in this case, 65,002 as the AS number. Once this step completes, I'll then register the recovery site. I'll copy the token from the main site and paste it into the recovery site by navigating to System, Disaster Recovery, Configure. I'll then select Recovery Site and enter the main site's virtual IP address of 172.21.21.10. The recovery site VIP is pre-populated with 172.27.27.10, and then I'll paste in the token that I copied from the main site. I'll then enter the username and password used to connect to the main site and click Register. Once this completes, I'll set up and then register the witness node. I'll go back to the main site and copy the registration command, then paste it into the witness node. I'll SSH into the witness node using port 2222. Once logged in, I'll paste the registration command, but be sure to edit the command to enter your username for the main site. My username is admin, so I'll delete the main underscore admin underscore variable and replace it with the word admin and press enter. Then I'll enter the password and wait for the registration to complete, which can be seen from the main site. Before I activate disaster recovery, I do have to set up my BGP neighbors that will appear with Cisco Catalyst Center. I'll log into the main site router and enter BGP configuration mode by typing config t followed by router BGP and my AS number, which in this case is 65,000. I'll then enter my neighbor statement pointing back to the enterprise VIP address of 172.21.21.10 with a remote AS of 65,001, which is what I entered in Cisco Catalyst Center. Then I'll activate it under the IPv4 address family and be sure to save the configuration changes with the right mem. Then I'll log into the recovery site router, enter BGP configuration mode by typing config t followed by router BGP and my AS number, which is also 65,000 in this case. I'll then enter my neighbor statement pointing back to the enterprise VIP of 172.27.27.10 with a remote AS of 65,002, which is what I configured in Cisco Catalyst Center. Again, save the changes with the right mem. Now that registration is complete on the main site, recovery site, and witness node, and BGP is configured within Cisco Catalyst Center and on neighboring routers, I'll go ahead and activate disaster recovery by clicking the Activate button. Now that activation is complete, I can log into Cisco Catalyst Center using my DR VIP address of 10.10.10.10. Navigating to System Disaster Recovery, I can see that the main site is active, the recovery site is in a standby mode, and the witness node is up. Clicking on the Show Detail information allows me to see more detailed information about the status of all three sites. This will show things like which one is active, the tunnel status, the BGP session status, etc. Clicking on the Physical tab will show the physical layout and status between Catalyst Center and the upstream routers. When logging into the physical router at the active site, I can see that the DR VIP is being learned from BGP from the neighbor at 172.21.21.10 or the enterprise VIP of my main site, which is active. Any traffic for 10.10.10.10 will get routed to Cisco Catalyst Center's enterprise virtual IP address. This is why you don't need to set up a separate network just for the DR VIP. Any traffic to the DR VIP will just get sent to the active Cisco Catalyst Center's enterprise VIP as the next hop from the router. So this is how to set up Cisco Catalyst Center's disaster recovery. So let's test out some failover scenarios. One way to test is to simply click the manual failover button. However, I want to simulate an outage to test the automatic failover option. I'll log into the router at the main site and create an ACL that blocks access from the witness node and the recovery site to the active Cisco Catalyst Center server. For an automatic failover to occur, the active site must be unable to communicate with both the witness node and the recovery site for 7 minutes. If it can communicate with either one, the witness or the recovery site, then it won't fail over. Communication has to fail for both for a failover to occur. I'll apply the ACL to interface VLAN 112, which is the VLAN for my enterprise VIP. After 7 minutes, the failover will begin. The main site will go into an isolated state, and the recovery site will automatically be configured as active. The recovery site will also start to advertise that DR VIP to its BGP neighbor. After roughly about 30 minutes, all the services will be up and running, the recovery site will be active and start advertising that address. It's important to note that Catalyst Center will never automatically fail back to the main site. If the main site were to go down and a failover occurs, the main site would have to manually be rejoined to the recovery site to re-enable disaster recovery functionality. Once it's rejoined and disaster recovery is up and running, only then can it perform another failover, either manual or automatic. To rejoin the main site to the recovery site, you just simply click the rejoin button. Now that disaster recovery is up and running, and we've tested the failover capabilities, how do we update Cisco Catalyst Center to take advantage of new features and functionality? Currently, we don't support updating the witness node. Therefore, anytime you want to upgrade Cisco Catalyst Center, you'll also need to download the same version OVA file from software.cisco.com. In order to deploy a new witness node, you'll need to deregister disaster recovery. To deregister, first you would pause DR by clicking on the three dots next to manual failover and then clicking pause. Once it's paused, click the three dots again and click deregister. Once deregistration is complete, you'll perform the software update on both the main site and recovery site, and then deploy a brand new witness node from the OVA file and re-register the main site, recovery site, and witness node, following the same steps as before. Once they are registered on the new version, you can go ahead and activate disaster recovery. So this concludes the video on Cisco Catalyst Center's disaster recovery. I truly hope this helps you set up DR in your environment. Thank you for watching.